Our first question is, what is a one-to-one function? Let me try to switch screen. Okay, the first question is, what is a one-to-one function? This is a conceptual question. So the thing to note for one-to-one function is that one-to-one function maps a single y value to an x value. Question number one maps a single y value to a x value. Let me zoom in a bit. Okay, so let's look at an example of one-to-one function. Or let's look at an example for some functions. Consider y equals root x. Is this a one-to-one function? The answer is, let's look at some values. So first of all, let's look at the value 9. So if y equals 9, what's x? It's just 3, right? Because and then let's look at 16. If y is 16, what is x? It's just 4, right? And if y is 4, what is x? It's 2. So here we can see for each y value, we're mapped to a single x value. So is this a one-to-one function? The answer is yes. This is a one-to-one function. One-to-one function. Now let's look at another example. Consider g of x equals to x squared. Is this a one-to-one function? So let's consider the value 1. If x is equals to 1, what would the y value be? It would be equals to 1 squared, which is also 1. However, if you consider the value negative 1, the x value negative 1, what would the y value be? It would also be 1. Here, we notice that, or don't write the other one. We notice that both the value negative 1 and both the x value 1 and the x value negative 1 maps to the y value 1, which means that this function, g of x equals x squared, is not a one-to-one function. So no. So here are 2 examples. Next, let's look at some graphs. So again, first let's graph y equals the square root of x. Y equals square root of x. Or the graph should be more like this. And this is the graph of y equals to square root of x. How do you know this is a one-to-one function? Another test that's really simple to test whether a function is a one-to-one function when you have the graph of it, and this is called horizontal line test. Horizontal line test. How it works is very simple. So basically, you draw horizontal lines on the graph, and you see all those horizontal lines you draw only intersects the curve at one point. So each horizontal line you drew intersects the curve of y equals the square root of x at one point. This means that this graph is indeed a one-to-one function. Yay! And next, let's look at the graph of y equals x squared. And this is just the graph of y equals x squared. It goes like this. Y equals x squared. And from now, if you employ the horizontal line test, you would see that the horizontal lines, it actually intersects the curve at more than one point. So you can see here, it intersects the curve at 2 points, at 2 points, at 2 points. This means the function y equals x squared fails the horizontal line test. Fails the horizontal line test. And the graph y equals x squared is not a one-to-one function. So not a one-to-one function. Another related concept is that we have the horizontal line test. How about the vertical line test? Does that exist? Yes, there is a vertical line test. It's not relevant to the concept of one-to-one function, but it's relevant to the concept of functions. So you can see that if we employ the vertical line test, the curve y equals x squared also only intersect each vertical line at one point, which means that y equals x squared is a function. Although it's not a one-to-one function, it's also a function. And you can see that y equals x, or y equals the square root of x, also passes the vertical line test. That means it's also a function, which makes sense, because if it's a one-to-one function, then it's a function. So the idea is that only one-to-one function passes the horizontal line test, but all functions passes the vertical line test. So that's the concept of one-to-one functions and how to find whether a function is one-to-one. Okay, let's look at the sample solution over here. Yes, they had a mapping. They had an example. Yes, great job or great explanation. Might be better to also incorporate the concept of horizontal line test. Okay, that's our comment, and the solution is correct. Now let's look at our second problem, which is loading. The second problem is actually really straightforward. How to convert centimeters to meters. So problem number two, convert centimeters to meters. So say you have, so the short answer is just to divide by short answer divide by 100. This is because centi means 100. So there's 100 cent. So in each meter, there's 100 centimeter. You also note the word century or cent. Cent it just means 100 in like Latin. So this is how you could easily remember that there's 100 centimeters in each meter. Now let's look at an example. Whoopsie. Let's look at an example. Let's try to convert 354 centimeters to meters. And what we're going to do, again, is we're going to divide by 100, or you would notice that 1 meter is equals to 100 centimeter. So you would put centimeter at the bottom because you're converting centimeters to centimeters, and this, and this, you want them to cancel out. So let's do 100 centimeters and 1 meter. So you would have 354 over 100 meter, which is very simple, which is 3.54 meter. And that's how you convert from centimeters to meters. So let's see. Yes, they have another example. We also have an example converting from meters to centimeters. And we give the explanation here. Let's just say perfect. That's correct. Okay, I'm going to, oh, the next question is simple, but I'm just going to quickly charge the laptop so it doesn't die. So the next question is, what is a fraction? A fraction is very straightforward. So a fraction is just kind of expressing how many parts of an entire item have. So for example, if you're eating pizza, you don't just eat like a whole pizza, you're eating a slice of pizza. So usually I would say you would eat 1/16 pizza, which is a slice. And sometimes you would eat 2/16 pizza, which is like 2 slices of 1/16 pizza. Or if you like to take bigger bites, you can eat 1/8 slice of pizza, which is when you divide the pizza by 8 parts, you eat one of the slice. So this is basic concept of fraction. Let's just write down here 3 fractions. So a fraction has a numerator and a denominator. Let's use the 16/2 example. And this is the numerator. The number on top is the numerator. And the number on the bottom is called the denominator. Denominator. And there are 3 main types of fractions. One type is called proper fraction. So 1/16 is a proper fraction. Proper fraction, because the numerator, or the number on top, is smaller than the denominator. Some other examples of proper fraction include 2/8, 3/4, etc. And then there's other type of fraction called improper fraction. Improper fraction. And the difference between proper fraction and improper fraction is that improper fraction, the number on top is bigger than the number on the bottom. So the numerator is bigger than the denominator. So if we reverse all the order of proper fraction on top, right over here, 16/2 would be an improper fraction. 7/2 would also be an improper fraction, and 8/3 would also be an improper fraction. There are also mixed fractions, so they are kind of a mix of whole numbers and fractions, but they're still a fraction because they're a fraction. So for some example would be 2 and 3/4, 5 and 16 and 16th, and 7 and 7/8. So yeah, here are some examples of proper, improper, and mixed fraction, and this is the concept of fractions. Perfect. They basically had the same explanation as us, and they had like a visual representation of the fraction 5/2 because you divide by an entire circle with 5 parts, and 2 of the parts are filled. So this is 2 out of the 5 parts, which is a fraction. It's not the entire part. It's less than the entire part, or more than the entire part in terms of improper fraction. Okay, let's say good job. That's correct. Perfect. So thank you for coming to the OneClass live stream today, and that's all we're going to cover. Hope to see you in the future.